Okay, this is going to be working through the test review for the first test of MATH201. I gave out this test review in class, and so I'm going to take some time and work through these problems. Don't know how long this will take. I'll probably go 20-30 minutes and then stop and then create a new video. And I apologize in advance. Hopefully I won't make any mistakes as I'm working these problems out, but it's always possible, so hopefully I'll be careful and do them all correctly, but I am human. So let's dive right in. So problem number 1, you're given a function, pretty straightforward function. Then you're given a bunch of questions to determine. Basically, there's a whole series of where they define x to be either a number or later on some kind of variable, and they want you to rewrite the function, in this case where x is 1. So once again, function notation means we've got our f function up here, 1 minus x squared. F of 1 says you go to your function, every place you have an x, you replace it with 1. So 1 minus x squared, but instead of x, I put in a 1. So 1 minus 1 squared, that's 0. The next one, f of negative 2, every place I have an x in my function, I put in a negative 2. 1 minus, now here be careful, because it's x squared, I put in a negative 2 for x, so I have to square this, so I put this in parentheses. So this is really 1 minus 4 minus 3, and then the rest of these, f of 0, 1 minus 0 squared, which is just 1. Here's one that's a little different. Instead of putting a number into the function for x, they say replace it with k. So I go to my function, every place I have an x, instead of putting x, I put a k. And then we go back to a couple more numbers. So negative 5, 1 minus a negative 5 squared. Like a negative 24. Now, you can put anything you want in here for x. 1 minus 1/4 squared. 1 minus 1/16. If you turn 1 into a fraction, it would be 16 over 16. So you're left with 15 over 16. And then there are a couple more. All right, this one's a little different. So now they're saying, go find f of x plus h. So basically what they're saying is, every place you have x, replace it with x plus h. So 1 minus x squared is going to be x plus h squared. Now most of the time they'll want you to simplify this by multiplying out these parentheses. Be careful now, remember your algebra. X plus h squared is x plus h times x plus h. So you get 1, and I'm going to put these brackets here because I'm subtracting this whole thing. So when I FOIL this and multiply this out, I subtract all of that. It ends up being x squared plus 2xh plus h squared. Of course, now when I get rid of these brackets, I subtract everything inside the brackets. And the last one, which will look somewhat familiar because this is actually the difference quotient. And we'll be doing some problems with this a little bit in order to find the derivative of some functions. So f of x plus h minus f of x over h. So I'm going to take my function I was given, 1 minus x squared. I'm going to first replace x with x plus h squared. So here's the f of x plus h. And I'm going to subtract f of x. Basically, I just rewrite f of x. All that over h. Now the good thing is, if you look, the problem up here, I already simplified f of x plus h, which is this right here. So if I just recopy this, it's going to be 1 minus x squared minus 2xh minus h squared. Now I've got these brackets here, minus 1 plus x squared, all over h. I want to combine like terms. 1 and minus 1, those cancel out. Negative x squared and x squared, those cancel out. And I'm left with negative 2xh minus h squared over h. Hopefully you can see these two terms in the top both have an h and h squared, and there's an h down here. I can cancel a h out of all three of these. And I'm left with negative 2x minus h. All right, so that first problem was just all about understanding function notation and how to substitute in different things for x. Problem number 2. This is called a piecewise function because the value of the function changes according to what your value of t is. In this case, the function is h of t, and piecewise functions are written like this. H of t is going to equal 2t plus 1 if t is less than 1. Let me write this out, and then I'll explain how this works. H of t equals 4 if t equals 1, and h of t is t squared if t is greater than 1. So here's how this works. If you're given a piecewise function, it's saying there are 3 possible expressions for h of t. And the way we determine which expression we're going to use is based upon the value of t. So what this says is, if t is less than 1, so if t is like a negative number, negative 5, negative 2, or even 0, if t is less than 1, this is what h of t equals. But now, if t ever equals 1, if someone says find h of 1, then this is the function you use if t ever equals 1. And basically you just say h of t equals 4. It's just a constant. But then also, you might have a value of t that's greater than 1. So if you're given a value of t of 4 or of 10 or of 20, then you use this third expression. And you would say h of t equals t squared. So really the way these piecewise functions work, for instance, the first thing we're asked to determine is h of negative 3. With a piecewise function, the first thing you have to do is you look at your value of t, and then you go figure out which expression is in play, which is the one you should use. So for t equal negative 3, obviously for that one, t is less than 1, So I'm going to use the first expression. Just to make it very clear, I could write it out. And now I plug in a -3 for t. It looks like h of -3 is -5. Then they say, what is h of 0? Well, once again, you go and figure out which of the three expressions you're going to use. Now for t equals 0, it looks like I'm still right here on this first one. So I plug in a 0 for t. A couple more, h of 1. So when t is 1, which expression do I use? Well, this one is when t is less than 1, but then the second one says when t equals 1. So it looks like there's really no math to do. It's always just a constant. It's always just 4. And then the last one, h of 2. Once again, first step, go figure out which equation I should use. So when t is 2, looks like it's this last one because this says when t is greater than 1. This is the expression. All right. So number 3 now, looking at that, is a problem about domains. I know through the years, my experiences, a lot of students struggle with the concept of domain. So hopefully when I explain it in class, it became more clear to you. So there are actually 4 separate expressions, and they want the domain of each. So let's just do some of these, and as I work through them, I'll remind you of what I explained to you in class. So this first one is g of x equals 10x cubed minus 5x plus 15. Normally, for most expressions we look at, we like to think of domain as all the possible values of x, and that's true most of the time. Although when we look at problems B and C, problem B is h of w, problem C is f of t. In this case, for this one, the domain is going to involve the variable w, so all the possible values of w, and in this case, the possible values of t. Really, the domain you can think of, you're really looking at what we call the dependent variable. An expression like this, x is called the dependent variable, g of x is called the independent because g of x depends on the value of x. That's why x is called the... Oh, well, see, I said it wrong. These are the independent variables. In other words, you can choose whatever you want for w and t. And in this case, I can choose whatever I want for x. In other words, I'm independent. But once I choose a value for x, then that determines the value for g of x. So g of x would be like my dependent variable. X is independent. I can choose x to be 2, x to be 4, x to be 10. It can be anything. But once I choose what x is, then the value g of x depends on what I choose for x. But for this case, it's a traditional all the values of x. And I said here is the way to think about domain. The domain is what numbers is it okay for x to be? And I always said whenever I start, I always assume the domain is all real numbers. That symbol is for all real numbers. And then there are only two things that are going to change the domain. First, if you ever have any variables under, how about write it like this? If your variable is under the square root, then that's going to affect your domain. Or secondly, if you ever have your variable in the denominator of a fraction. If I don't have either of these, then my domain is just going to stay all real numbers, which means x can be anything. So for this example, I'm going to assume it's all real numbers, and I look. Do I have any variables under square roots? Well, no, I don't even have any square roots. Do I have any variables in the bottom of a fraction? No, I don't have any fractions. So you know what, for this one, my starting point is all real numbers, and that's where it stays. The two situations that would cause the domain to change, neither of them are present, so A is all real numbers, which means x can be anything, which makes sense, right? You can plug in any number you want for x, and everything's going to be fine. The reason why these are a concern, because when you have these kinds of situations, there are certain numbers that are not allowed. And we'll see some examples of that in a minute. So that was pretty simple. Let's go to B. H of W equals 4w squared over w squared plus 5w minus 14. So in this case now the domain, my independent variable is w. So I'm looking for the domain of w, which basically says what numbers can w be, or maybe what numbers can w not be, to think about the other way around. I'm going to assume all real numbers to start with, and then I look, do I have any variables under a square root? There's no square roots. I also say, are there any variables in the denominator of a fraction? Yes, there is. So my domain is going to be affected by having variables in the denominator. Now in this case, what I need to do to be able to determine my new domain, I need to be able to factor this, and this in fact does factor. And I believe it will be w plus 7 times w minus 2. Now when you have variables in your denominator, the reason we're concerned is we have to make sure we can never ever have a 0 in the denominator of a fraction. And I've got these two parentheses multiplied together. If I look at this first parenthesis, I ask myself the question, what value of w would cause this first parenthesis to be 0? Because that number is going to be a problem. I've got to make sure w never equals that. Matter of fact, I can say basically, I can never let w equal negative 7. Because if w is negative 7, this parenthesis is 0, the whole denominator is 0, and you cannot divide by 0 in math. If I look at the second parenthesis, I know w cannot equal 2. So what's my domain? Here's one way you can write it. The domain is going to be all real numbers. That's my starting point. The domain is all real numbers except negative 7 and 2. So if I look at this expression, w can be anything. Let me just write it like this, it's a little more clear. Domain is all real numbers except negative 7 and 2. That's what w cannot equal. All right, two more. We go to C. Let's see what kind of expression we have for C. F of t equals 10t square root t minus 4. So here we go again. My starting point, I'm going to assume the domain is all real numbers. And then I look, do I have a variable under a square root? Yes, I do. Do I have a variable in the denominator? No, I don't. But I do have the square root here. So what do I do there? Well, my main concern when I look at the square root is I've got to make sure the one thing I cannot have in my expression or in math in general, you can never have a negative number underneath a square root. You cannot take the square root of negative numbers. It's impossible. So we have to make sure whatever value we choose for t, we have to make sure that we never have a negative number underneath the square root. So the way I can figure it out is that's another way of saying, you know what, I really want this to be in here. This needs to be greater than or equal to 0, right? Which basically means it needs to be a positive number or it can also equal 0. I need whatever is underneath the square root to be positive. So let's just write that out as an inequality. I'm really saying t minus 4 has to be greater than or equal to 0. If I get t by itself, add 4 to both sides, t greater than or equal to 4. Now sometimes for this kind of problem, just to make sure I don't get confused, when I have an inequality, a lot of times I just like to draw it on the old number line. So if this is t, and say 4 is here, t greater than or equal to 4. So this is now my domain. If I want to write it as an interval, it starts at 4 and it goes to infinity. So the domain for this expression just says t has to be greater than or equal to 4. Now some of you might think, well, what's the impact of this other t on my domain? Well, this other t has no impact. I can never put in a number for this t that's going to be a problem. The only things I have to worry about is when you have variables under the square root and variables in the denominator. So this t, no impact on the domain. Okay, the last one, f of x equals square root of x plus 3 over x squared minus 25. Actually, most of these problems like this, the first thing you should do is go and factor. So before I even try to figure out the domain, let me just factor this. This is a difference of squares. All right, so now I assume my domain starts out with all real numbers, and I look for the two exceptions. First of all, I look for, do I have a variable under the square root? Yes, I do. Then I say also I have to look for variables in the denominator. I have that also. So this is a case where both sort of exceptions, both things I have to look out for are occurring at the same time. So I have to take into an account the effect of both those. So how do I do that? Well, here's how I do it. I start out looking at the square root first. So I know I have to make sure whatever is under the square root, that has to be greater than or equal to 0. If I solve for x greater than or equal to negative 3. And like I always do, I'm going to sort of plot this on a number line. So if I say negative 3 is here, so as of right now, because of the impact of the square root, I can say my domain is going to be everything greater than or equal to negative 3. But now I have to go in and take into account what's going on in the denominator. Now if I look at the denominator, what's going on? Well, there are two values that I know x cannot be. X cannot be -5, and x cannot be 5. Now, if I go over here to my number line, if I look, -5 is over here. You know what? Because of the square root, -5 has already been sort of eliminated. It's not part of the domain anyway, so I don't really care about it. However, look at where 5 is. 5 is like over here. If it was up to the square root, 5 is a perfectly fine number. It should be in the domain. However, the denominator says, wait a second, 5 is not okay. 5 cannot be part of the domain. So how do we take into account both of these, the square root and the denominator? Well, what you do is you start here at -3 and you go to 5 and you stop because 5 cannot be part of the domain. So I'm going to stop there with a parenthesis, and what I'm going to do is I'm going to sort of skip or jump over the 5 and then start going again. So to draw that, they do this thing where they draw back-to-back parentheses, which means just skip this point and then you keep going. So really you have two intervals. The first one goes from -3 to 5, but it does not include 5. And then the second interval starts at 5 and goes on to infinity. So the way we'd write the domain is from -3 to 5 with the parenthesis, and then we say we union. The union sign, which says both these intervals are part of the domain. And we start again at 5, not including 5, and we go on to infinity. All right, so that's the first 3 problems. Let me go ahead and stop here now, and we'll start a new video.